broadcast. Okay. Let's see if I can hear myself again or not. So can you see my screen now? You can hear me. Can you see my screen? It doesn't seem like I can hear myself again. So maybe it's working. Okay. Continue this. So I'm going to do actually. Let's see. Slide each other. Okay, perfect. Okay. I hope everyone's following along. If not, you could just watch me going through the lab. It's pretty straightforward. You could also do it on your. It's a self-paced quest. So we are logged in into our account, the student account that Google provided us to do this lab with the free credits. These are just basically telling you what you're going to learn about HTTP protocols and methods, and the APIs, the endpoints, JSON, which stands for JavaScript object notation, and the authentication services on Google. For prerequisites, I would say just don't worry about it for now. They pretty much put everything on the steps here. And so we actually gone through this for now. This is telling you like exactly what we just did. We accept the term and condition, and now to the API. So what an API is, it stands for Application Programming Interface. This is basically how we make two different products or softwares talk to each other. A lot of you're using APIs every day when you use your mobile phone or your computer, or maybe even in the TV watching things. And this is the way how software works. You're a client. You're looking on your phone. You want to get for instance, your calendar. You pull it up, so that goes like if it's your Google account, that pulls up uses probably like Google API for your calendar or your email or whatnot. It's the same thing. So the cloud APIs is the same idea. Cloud APIs because they are on the cloud and Google services. And in this quiz, we're going to be learning about how to use the Cloud Vision API and the Natural Language API. So there is a big library that you could look at in the Google Cloud for APIs, and here they're just going to show us an example of a fitness API that we could use, or just to test. So we could go, it tells us here in the search, we're going to go to look at APIs. So navigation menu, this is navigation menu right here. You have everything that mostly used pinned to your this sidebar. So navigation menu, API services, and you're going to go library. This is where you could search for a lot of the APIs they have. In this case, we're going to look into the fitness API and hit enter, and we're going to enable it. And you're going to see some check sign here that it's enabled. So it takes us directly to the actual API page. If we go back, let's say library fitness API, you can see here it's enabled. So we were here. So we're gonna try it out. So it tells us here, enable API. So we are here actually. And if you go to this manage page, it tells us that we could look at quotas, everything. Each of these APIs has different quotas probably, or how many hits you could hit it per day or per user. And of course, it's like you pay for these services. Right now, we are just using free credits, so we're not going to be paying for any of this. So quotas, what is it telling us here? It's this feature quotas, expand request option, request. Oops, requests per day. So there's a limit of 864,000 hits per day, or requests per day for this endpoint, for this API. Okay, so answer the following multiple choice. Offers a quick access documentation and configuration options for 200 plus APIs. So API library. Details your project uses of specific APIs, including traffic levels, error rates, and even latencies. So that's API services. Okay. So this is more knowledge here about learn about the API architecture. So as I mentioned, an API is like the server. In this case, if you could look here, client server model. So you're the client, and you want to get something. Let's say an analogy that's always used for an API is like if you go to a restaurant and of course you want to get food, and the server is the kitchen. So the waiter is basically the API. You use it to go to call the service basically, or the server, to get your food from the kitchen overall. So you are the client. You can use your computer, monitor screen, iPad, mobile phone, and this is how it works. We use APIs all the time. So HTTP protocols and request methods. So for every API or endpoint that's probably implemented, we could use. There are these methods that we use typically. So there are get, put, post, and delete. So get is when you want to fetch data from a server, and then put if you want to update some records on the server or in the database. For instance, if you have Facebook account, you're updating your profile, change your email, your phone number. You probably use a put, HTTP protocol or request, and post if you want to actually create a new record. When you create a new account anywhere, use probably a post request, and delete is to delete the record on the server. So all APIs work in the same way. So at the end of the day, they all use the same protocol and methods to communicate between a client and a server. Just understand a computing device that makes a request for some community resources, data. This is a client. And an HTTP method commonly used for creating new resources, that would be post. Endpoints. So you probably saw this a lot, right? These URLs. So these are what we call endpoints. So for instance, here they're mentioning, as an example, .com accounts. So this would, you would look right away. When you look at something like this, you're probably reaching an account endpoint, right? Employees. So you want to get accounts from that endpoint, or you want to get here. You want to get employees. You want to might delete an account or create a new account. Here, you're getting data. You might be getting data on store location, San Francisco, or different locations depending on the endpoint. So you actually could implement things like that and use queries to actually fetch data from these endpoints. So for GET requests, we use something like query methods. So something like if you want to get to if you want to get on, this is an employee's endpoint, but if you want to get to one employee, for instance, get data on one employee, so that would be, you would add a query parameter, what we call it. That would be something like this. So ID 1, and that would reach like that one person, employee, or one account, for instance. And then for this is basically what it's saying here. And then for a post request, we use parameters that are included in the body of the request. So it's the same idea for pretty much GET and POST, but again, GET, we're fetching data, POST, we're creating data, and we just use different terminology. When we use like we use GET, we call these parameters query parameters because you are querying basically a database, and for POST, you are putting an object, like let's say a hash that you want to create a record in the database. So that's what we call it, like these body parameters. Of course, every endpoint has like validations and whatnot. So you might have like keys in your database that can't be null or whatnot. So of course, you're gonna, for any endpoint, you're gonna have to read probably documentations to be able to know what goes in that, what parameters you're gonna have to include to actually get your request done properly. RESTful APIs. It's so APIs that utilize the HTTP protocol request method endpoints are referred to the RESTful APIs. REST stands for Representational State Transfer, and it's an architectural style that prescribes standards for web-based communication. So there's more documentation on this. It's same idea. Anything that communicate pretty much between client and server, RESTful API. This is just more terminology on pretty much the same thing. So nothing to worry about here. Resource-oriented design. So there's just more talk about RESTful APIs. So these terms should sound familiar since you examined these in the previous sections. Maybe not, because we didn't examine. REST is the most widely used framework for APIs. Of course, everything is REST. 2010, about 74% of public networks APIs were HTTP REST APIs. So as I mentioned, headers. Headers like what includes the metadata for your endpoints, and again, you're gonna. This is what we're gonna actually be doing today with our post request to the endpoints, to the APIs that we're going to be calling. But just to know that we're going to be putting data in headers that we're going to be the API key that we're going to create to be able to, or to authenticate or be able to use the endpoints. And the body is what's, so any post request is going to have a body, and that's what we're going to put in that request. So we could, use the endpoint properly and create or process our data. And you could use JSON or XML, but what's mostly used nowadays is JSON. It's easy to work with more than XML. And I would just, so go on JSON here. I'm not sure if XML is included actually, but so the JSON
stands for JavaScript.
Object notation. It's been widely used for in APIs and for anything pretty much. I've pretty much worked with XML like maybe once in my life when I was at university, but since then, with all of my different careers, I've been using JSON. So it's a key value, it's a hash, or in a dictionary, in Ruby, I guess a hash, in a dictionary in Python, look like a dictionary. It has its own, I guess I usually use something called JSON lint if I'm trying to make a JSON, I want to validate it if it's done correctly. If I'm putting a couple of key values together to maybe call an API or something. But this is just going over like how you could use like an integer or a number or a Boolean. So it's pretty straightforward. You pretty much use similar to this in Python dictionaries. So this what would a JSON look like if you want to have let's say a body request that has a name, hometown, age, for instance. So this would be a string, and this is an integer value. So yeah, they actually mentioned here the JSON lint. So this is I'm not going to click on it, but you could look at it. It's just you could copy paste your your object or JSON you're trying to build, and it just basically validates it for you. Yeah, it's pretty straightforward. And if it's not validated, for instance, you have something like this, you're gonna have an error, and it's gonna tell you what's going on, right? What's it's expecting and what you should put it in instead. So it's this, and we really go over this just for the sake of time, but pretty straightforward stuff, and it's just like go quickly your access points, data, or community source in a server, and you take the formula should be URL. This would be the endpoint. An architecture style that describes standards for web-based communication. That would be, oops. Okay, maybe I need to read more of this. A file format that is lightweight, easy to read, and fast to parse. I guess that's a JSON. Pretty sure. Well, this is pretty vague. Java is easy to read for file format. Java file format. No, array is just a data structure. I think JSON was also a data structure, but it's easiest one to work with and very lightweight. So that's the reason why everyone is using it. Create a JSON file in the Cloud Console. Okay, so I think we're gonna be just doing this very quick. Cloud in the web. You can apply your knowledge about the REST JSON API in the new tab. Open Google Cloud Storage. Let's open this in a new tab. Values, where are we here? So we're going to use this. It's enabled already to ensure, so it's enabled. Now open a Cloud Shell. So what we're going to do here, come here, and this is the tab for anywhere you see activate Cloud Shell. You're going to probably come and put on this, click on this logo here, and it pops it up from the bottom. Just give it a few seconds, and you're going to have to probably anything else? No, that's it. There's nothing here in the directory pretty much. So we're gonna create this JSON. This is just a test in our knowledge or make sure we know what we're doing. I don't use really nano. I'm gonna use Vim. Values JSON, and if you put the the suffix or JSON in a weird way, it's gonna just create basically a text file, and you won't see the whatever you put in that file. It won't be color coded. So it happened with me. I'm like, what's happening? And then I realized I'm saving this file in a weird way. So let's see. We're gonna copy paste here. Name, your bucket name. So we're doing 7 as let's put like, yeah. What is this? So I'm gonna use GCP O2. I usually use like the project ID a little bit when I do bucket names in these sessions. Just it has to be unique in a way because these a lot of these are the bucket names that we're working with. Well, the buckets usually it's actually public, so anyone could see data, I believe, unless if you really set it to private. And I think mostly we're going to be using like public. I think there was one instance where we made it private, but that's why it has to be unique name. So it's easier to, and then C F3. So escape on WQ that saves in Vim. Once you have exit one of them. Oh, so it tells you here if you're using Nano, it tells you how to save and exit. I'm not comfortable with Nano. Just use whatever you're comfortable with. Nano, there's Vim, Emacs, whatever you're comfortable with. So we just created if you list whatever is in that directory. So ls is better. Just you're gonna make sure you have the values. And if you list that file, it's gonna show what you just saved in it. So that's a JSON file. And make sure it's .json at the end, right? So we need to do some authentication and authorization on the cloud. So again, this quest here is or lab is an intro to all these functionalities and features in the cloud. But we're going to be using when we use the Cloud Vision or Natural Language API, we're not going to be doing this specifically in detail like this. We're going to actually the lab itself is going to give us all the commands that we're going to use in the curl commands. Pretty lengthy lab here, but it's has a lot of details. So I would suggest that you go over it on your own time and take your time on it. So the API keys is these kind of secret codes or tokens, and it's encrypted. And this is what we use to communicate with the platform or like with APIs. So API, well, it says API key, so I guess it's APIs. So that's how you identify yourself and to the basic platform. Again, it's encrypted, so that's how you get a response back, a successful response or 200 code response. So there are more secure and can be linked. So that's an authorization token, I guess. So API keys, it's so this is so there is authentication authorization. I think this refers to like authentication. So you authenticate yourself. So it's similar to API keys in their format. So they're more secure. They can identify you as a user on the platform. So yeah, so this is what we used to access data. Validity of client IDs are all based on scope, different privileges. So. And yeah, so based on whatever we're doing, you get different privileges. If you're reading data or you're using get method, you at least have a read permission or privilege. And if you're doing any, for instance, post request or delete or put, you're updating something, you must have write permissions or write privileges to the endpoint or the API. And this is by default. Google is going to be doing all this for us in the back end. We're just going to be using it or utilizing it. Authorize. Okay, so we're going to be creating API key authorize. For the access to your data, you need to generate an OAuth token before you use its services. So open the playground in a new tab. Let's see. And we're gonna, where did we go here? So scroll down, cloud search. So we're gonna go SaaS or go search here. 5v1 and full control. So I guess we're giving ourselves full control. As you can see, there is a read-only, read-write, full control. So that's good. That's our scope. Click on the authorize APIs. Just because I'm an incognito here. So continue. Okay. So I think might be saving something here. Exchange device. That's what we're seeing. So now have an authorization code. Click the exchange. If you get moved to step 3, click on the step 2 panel view page. Let's click this. We created the application of access token. So we're going to be copying the access token, right? So it's this one here. So it tells us here it's going to expire in 2,545 seconds. Copy that following steps. So let's copy the access token. That's all we need. Maybe as we're gonna run call some APIs. So that's why we need it. It tells us the scope again here and more metadata. So okay, so we're going back on our Cloud Shell. So we're gonna export so what we're gonna do is we're gonna create an environmental variable when you see something like this, export something, because we don't want to be doing it all the time. We're just gonna use this variable, which is much easier to deal with code or with any commands we're gonna be using. And as you can see, we're gonna be using curl commands to call these endpoints. So as you can see, this is how we're going to be calling this environmental variable. When you hit this in the curl command, it's going to extract this from your environment or whatever this variable got stored. So let's run this. So we already copied the access token. So auth2 token, and you paste your token. And if you want to just make sure you have that variable in your environment, you could do echo and auth2 token, and you should return the token that you just pasted. And then the project ID, we're going to also do that, so we don't have to put it everywhere. Project ID. So this is basically our project ID. Or you could just get it from here. It's the same thing. And echo project ID, and that returns project ID. So that's perfect. So we could copy now this curl command, and as you can see, it uses whatever we just saved as an environmental variable. So what we're actually doing right now is we're creating a cloud search bucket, and I think this is what we're gonna be uploading that file that we created. If you do ls again, you should have still the values there. But let's see. So we copied this curl command, and we hit enter, and this is telling you a bunch of stuff. So it actually shows it here. Let's just backtrack a little bit. So we created this values JSON file. So actually this is what we just did. We used a post method to actually hit the Google Cloud API storage API, because we want to create a bucket. And this is what we put in the body of the request. We put the name of the bucket, the location, and the storage class. And I know we just copy pasted that, but if you read the documentation and if you want to create a bucket, it's going to tell you that you at least maybe have to, these are required variables or parameters to be able to create the bucket that you need. So I guess it worked. And this is showing us that the data on the bucket that was created. So actually, we're probably going to go and see the bucket right now. So we use the post HTTP method to actually call the this API endpoint. Actually, it extends to here, and in the body we put the values.json that we just created. That's what we used to create the bucket. So we gave it the data that we needed to use in order to get us our bucket back. Okay, so here newly created cloud storage bucket. We could go navigation menu, and then we go to cloud storage and click buckets, and you should find this. It says GCP 028F3. That's what I named it, and it's there. And if we check our progress, and it should show us green because it does this automatically in the back end. Okay, so what we're going to do is upload a file to the cloud storage. So I think it wants to save this demo image. Let's see, demo. And I would suggest just to name it the same as what's the lab saying, just so, because if you're copying commands off the lab right directly, you don't want to go and start modifying. I guess I said before, you don't want to start modifying these commands, or it's might as well just, as you can see here, it's using the same name that it told us, so we don't want to change that. Okay, we didn't do it. We didn't upload it yet. So we saved this image. Cloud Shell. Click on three dotted. So it tells us to click here and upload and select demo image. Okay, so we do upload. Choose file and demo. Upload. So it should be in our directory, as you can see. Demo in image right here. Very small there. Maybe I should increase this a little bit more. That's better. Okay. Just gonna, get the path of this image in our directory. And now we wanna image path. So we wanna save this path into an environmental variable again, because we're going to use it to probably upload this image to the bucket that we just created. Object, and then again, if you want to do that, just to make sure this is saved. And we didn't do the bucket name yet, so we should do that. Export bucket name, and should be anywhere, probably find it. You could just copy it from here as well. Go bucket name, here it is. And now we're going to use a scroll command. So it's a post request. We're going to use this environmental variable that we saved with the object, which is the image, and we're gonna upload it to the bucket. So we have our bucket name that we already created. Sorry, the object is gonna be from our directory in the Cloud Shell where the image resides, and this is just saying the name, bucket name, and upload type. So let's just do that, and let's just refresh this. We have to go to the bucket to see it, and it's right here, the image. Perfect. And it tells us to see the image, go to see the bucket. We did that, and let's see if we are completed our task properly. Good. Okay, it's perfect. So we just finished this lab pretty much jumped over a lot of details, I would say, but it's pretty straightforward, and I would suggest to go over it and take your time, because the next lab is it's not, we're not going over this information again. We're just going to be using whatever we learned here in the next lab. So just to understand the theory behind this, maybe go over this lab. Okay, I'm gonna say end lab, and it's 11:17, and I'm gonna go open the next lab. That's gonna use, I think, a lot of um, the cloud APIs in one lab. So let's see. Let me just say this. Once you finish this, I usually just like close it, or we're done with this. Every lab is you're gonna have to open this again, and so I think it's even a different student account that you get. So I usually typically close everything. I don't need anything. Okay, so it's the same thing every lab. I just do start. Let me just actually, before this, so I could put them beside each other. Start lab. Use your credits. You just save the password and open this in incognito window. Then next, put your password. So look into your new account. So again, every lab you have a new account, so don't worry about saving anything. Or these are just purpose of all these is to learn, and you could always go back and do things again anyways. So I'm gonna just put them beside each other here. Okay, so we opened sometimes I click this just so I save time until I get to the steps if I want to use it, because it takes like a few seconds. Okay, so this is a new lab that we're going to be using now, the cloud API. So before we use the Google API, which was the bucket API, we were able to create a bucket. We created a JSON file. We used a post request to create a bucket, and then we upload an image to our Cloud Shell, and then we used another API call to actually upload this image to the bucket that we created. Okay, so that was a good test. Now we're gonna dive more into some other APIs. So we're gonna be learn about creating a vision API request and using the curl command as we used before. And again, the curl is I don't know what actually stands for, but it's not the. Let me just go to chat. Okay. It's not the only way to use APIs. If you write in for instance, I work. We use Ruby on Rails. We use the Ruby language to write requests, to implement requests for different APIs. You could use Python, whatever, any language you're working with, pretty much. You're going to be able to call APIs, and you have different methods, of course, different ways. Of course, the syntax is different. But what we learn in post, put, get, delete, these are like the typical methods that every API utilizes or uses. So you're gonna probably hear this all the time if you're working with APIs. So we're gonna be learning about using the text detection, OCR. OCR stands for optical character recognition. So we're gonna use that to we use this method from the Vision API. Using the translation API to translate text from an image, and using the natural language API to analyze text. This might be also going to be a lengthy, so we'll try to finish it before the break. But again, you could go and do it on your own. And we're rushing right now just for the sake of time. So So we did all this. Everlab does the same thing at the beginning. So we activated the cloud shell already. Okay, we're gonna authorize. Then you're gonna hit authorize, and this shows you your account ID. And then use this to active account. The name of this account is to be active. And then do your account ID, and then this what this does is it just shows you your project. So this should be the same as this one here above. Yeah, you don't have to run them. Pretty sure this is all the time correct. Okay, we're gonna create an API key. So it tells us to go to the services, APIs and services, enable API and services, and then probably gonna be able to. No, where did it tell us to go? Sorry, API and service credentials. Okay, sorry. Credentials. Create API key, and here you're gonna copy this. And then close it, and you could right away export API key, so you don't lose that. Just to make sure it's there. Okay, so we did that already. We copied it, we put in a parental variable, and check our progress just to make sure we are okay. Good. So now we are gonna upload an image to Cloud Storage bucket. So we're gonna create a bucket again here. Here we're gonna be using the UI. So this is even much simpler. If you remember how we did it before, we created a JSON file, and then we called a post request to create the bucket. So now let's give it a name. So yeah, usually I just do something like this. Intuition. Sure, it tells us here the steps. I think the most important thing is to uncheck this, enforce public access, prevention, and fine-grained, which specify access to individual objects by using object level permissions. Okay, so we're going to use have a specific access level for individual, so for yourself basically. Continue, and then create. Pretty sort of straightforward stuff. That's creating a bucket. Now we want to use this image to upload it, so you could save the image, sign.jpg. That's what's requesting us. So I would just use the same name that they want us to use. So you're gonna navigate to the bucket that you just created, upload files. So we're already here. We're gonna upload this file. And by the way, if you have any questions, just throw it in the chat. I might have. Let's see if I missed anything. Okay. Thanks, Rohan, for recording. I totally forgot about that. Okay. Let's upload. What did we just sign JPEG? Here it is. Let's upload this image, and then now we're gonna edit access to this image. So click add entry and select. Okay, so if you see here, there's the 3 dots telling us to go to. This is how you could edit access to the whatever image. We're gonna add an entry because we did the fine-grained, so we were able to come here and do something like this public. So we're preventing what we do. We said enforce public access prevention. So we preventing the enforcement of that. So as we could do all users public. Save. And let's check our progress. I think I forgot to do this last time and this wasn't working. So just make sure you do that. So as you can see here, under the public access column for this image, you can see it says public to internet. So anyone could come and see. This is something you could do if you're, let's say, you could host your website actually in a bucket, Google storage. And if you have images that you're storing here and you want to display them on the website, for instance, you have to do something like this. And this is the same in other like cloud web services or like Amazon, or you have to do something like this so actually the public can see your image. Because if you're storing it on the cloud, you have to give access to people to see it. Otherwise, it's not gonna show up. Okay, so create your Vision API request. So now here's the fun. So this is a JSON file. We're kind of familiar with that, key value pairs. This is kind of nested. There's a nesting in it. So you can see there's an image and then there's another source object in there. So we're gonna copy this, and we are gonna have to, whatever you see the bucket name here, we're gonna have to put the bucket name that we just created. So again, I use Vim. You're gonna name it OCR request, OCR request, and the JSON. Don't forget the JSON. OCR. OCR. We're in this quest overall. We're not gonna be talking in detail about like how these API work in the back end, like how, for instance, OCR can extract characters from images, or this is basically what it does, right? Optical character recognition. So it recognizes anything, characters in an image, and extract it. I worked with this in previous job where we used it in Python. It's a library from a library called Tesseract, and you do the same thing. You write a JSON file, and you do a request to the endpoint, and in that JSON file, reading the documentation. Of course, I remember reading the documentation, trying to understand what kind of parameter you're going to send in, and to be able to, for instance, if you have a paragraph that's on a document, or you have like one letter, for instance. So there's different configurations to help the API actually, because it uses machine learning, like neural nets, to actually extract these characters. So it helps it better to extract the text that's on an image or a scanned document, for instance. So this is basically what it's going to do for us. So we're creating this. We didn't create it, so we're going to create this down, and going to change the bucket name. Just make sure you have everything correct here. Save and exit. So we're going to use the type of our OCR. We're going to do is text detection. I think max result probably, I would say, doesn't say anything here, but you probably could click here and read documentation. Text max results are maybe 10 words that you want, or you're assuming that you want to extract. So here's the post request. So we're going to call this Vision API text detection method. So the header has application JSON type, and the data we're sending is inside the JSON file. And this is the URL, and we're sending the API key to be able to talk to the API, right, that we created previously. So copy this. Everything is already there. Hit enter, and this is the output. Let's look at it here, or a chunk, a piece of it. The first part of your response should look like the following. Okay, so it gives you back like coordinates x and y of like. I guess this would be this piece here. So there is a new line. So the coordinates of this piece of text on the image, and it actually detected that it's French. And then, so this is the first. So this actually, the first chunk is just telling you about the whole text, because this is the whole text from the image, right? And this comes down and starts actually breaking down the text and telling you, giving you more specific coordinates for each text. So if we had LE, if you want to go quickly with the image, I guess this is where it is right now, LE, and the coordinates on the image, you know, it starts from top left to the bottom right, the coordinates. I believe that's how it was remembered, but could be just maybe slightly different. Again, probably would tell in documentation, but usually that's how it goes: top left to bottom right, and then breaks down again every word that it's finding. So that's pretty neat, actually. So those our method is able to extract lots of text from our image. It's awesome. Let's break down the response. So it's telling you that the first piece of data, it's the whole text annotation, and then it you get an object after for each word in the response. Okay. So let's run this command. What's this gonna do? We're gonna save the response to a JSON file, and we're gonna see why we're doing that. Let's do that. So let's do ls, and we should have an OCR request and OCR response right here. I feel like this is small again, so I'm gonna increase it. So this is what we should have at this point in our directory. Okay, so sending text from an image to the translate API. So now it's the next step. We're going to be using the translate API, and we already got the text from the vision API, and we got it in response. So this translate API is going to be using this JSON OCR response JSON file. So what is this going to translate request? Create translate JSON file. Okay, the translate API can translate text into 100 plus languages. That's awesome. You can also take the languages of the input text, translate the French into English, because as you could see, it detected it's French and it looks French to me, even though I won't know. All you need to do is pass the text and the language code for the target language, English, to the translation. Create translation, request JSON. Okay. So we are gonna actually create a different JSON for the translation API, but we're gonna use the text that we're gonna extract the text from the OCR response. So let's create this, call it translation request JSON. Okay, that's about it. Save this. We want the target to be English. It's gonna go, but just if you wait a second here, what we're gonna be doing, they're gonna give us a command that's actually gonna take the text from that file and save it into this translation request file. So that's what this is doing. So if you do cat, for instance, translation, this is how it looks like. After that command, you're gonna do cat, and you're gonna see that your text has been saved into the queue area, or I would say it stands for query of that new transition request. Okay, so we didn't have to do that. This is what I mean about these things like easier. This is just a command line does this. You could do it in code. You could go and extract it in many different ways, but it's done now, so we don't have to worry about it. So now we're gonna use the post request to process the data and return the text in English. So this is gonna be the API call or the endpoint for the translation API. Again, we use in the header, we send the content type application JSON, and we send our data that's in the JSON file, translation request, and this is the endpoint and the API key. And we want, and this puts the output -O. This stands for the output file, and deposits the output right into the translation response. That's awesome. So copy paste. We look again and then get our translation response, and it should show us the thing in English. So this is the output of the translation API. Data, nested dash, or JSON object, translations, and then translation text. The public good, the dispatch is for Obama. The mustard is from Tijan Atiline. So it's not perfect. So I didn't really understand anything there, but that's what it is. So to the public good, the dispatch is so kind of like a bit different. So I didn't think contain result translation. I think there's a language code for French. Okay. So it's telling you the source language as well. So it detected that. You might want to do more analysis on it. There's okay. So now we're gonna do more, I guess, analysis on this text. So we're gonna be using the natural language API to do that. Okay. So to set up the request, we have to create the JSON file. So body of the request. So if we copy this and we call it NL request, sorry, it's just to first create the JSON request JSON, and then copy that, and then save it and exit. Support type values are plain text or HTML. So you could actually change this to HTML. So it just gives you the format in it. If you are actually adding in plain text, I guess that explains itself. Pass the text to send the natural language API for analysis. To send the file from you would replace content. Okay, so if you are sending, you just saying change the content. So in this case, we're just going to add our content, I believe, here. But in other cases, if it's on the cloud storage, you use content to be GCS content URI. Encoding type tells the API which type of the encoding to use when processing text. API will use calculate. So this helps the AI to calculate the specific entities appear in the text. Probably copy this. So this is how we're gonna get the text into the content area. Just copy and not worry about anything. That's just gonna do that for us. So if you request, so that we have the content there ready. Okay, so we're gonna use the post request. Okay, so here, see time. Okay, 20 minutes. I think we're almost there. Call analyze entities endpoint. So we're calling this endpoint in the natural language API. Again, using an API key, the natural language request, and this is gonna give us analysis on the text. Let's see. Copy this. Use that. This is the output. So this is how it looks like here. If we start looking at it here, let's see, it's pretty lengthy. So just giving us analysis on the text name, dispatches type, other. So it didn't give us type. I would say this is the entity type, of course. Metadata. Some others have metadata, I think. Okay, and then text. Sorry, salience. Mention. Let's see what salience means and mentions. Okay, when it was mentioned in the text, I guess. Begin offset 23. I think that's after 23 characters. Same thing for mustard, I guess. let's see this one. This one was more metadata on it. So I guess when it finds like data from like Wikipedia, it includes it here. MID, I believe, is something to do with on the cloud, like on Google, that they use this kind of code. I think it mentions here. Let's read this. For entities that have Wikipedia pages, the API provides metadata, including the URL of the page, along with the entity's MID. The meta is an ID that maps to this entity in Google's knowledge graph. So I guess you could read more about the Google knowledge graph that's something to do with their database, and where it's mapped on their graph. So this is kind of like a code. Passing for all entities, the natural language API tells us the places it appears in the text, dimensions, without entity, the salience. So salience is between 0 and 1 range, indicating how important the entity is to the text as a whole. In addition to English, the national language API supports the language. So I guess we could read more about this documentation. Looking at the image, it's relatively easy for us to pick out important entities, but if we had a library of 1,000 images, that would be much more difficult. So yeah, so that's actually pretty neat. And I think there is a next lab that's coming up where we're going to be extracting entities or similar to this. I think that's going to be extracting entities from the text. So let's just check our progress. If we didn't miss anything, that's awesome. Okay, so we are finished this lab now. Just telling you information about what we've covered. So we were able to, I think we used pretty much the post requests all the way down throughout this lab, and that's what we're going to use all the time because we are processing data. And we're using the API calls to process our data that we're given it. So we always use a JSON file that we use in the body, in the request body for that call. And we use 3 different APIs this time. We use the Vision API, Translation API, and Natural Language API. So we got an output from our the Vision API that kind of gave us the text with its coordinates where each word is present. We to give it to a Translation API that detected the French the text, and then we told it we want the translation in English. We got that JSON, and now this is just more analysis on the using natural language. Okay, so I think we could see if there's any questions. I'm gonna end this lab here. And see, 45, 11:45. We might be able to actually start another one, but I think we should go into in a break a little bit. Okay, we're gonna go back, exit, finished here. So we classify. I think this is the next one. I think we should go on a break here. Let's see the here. Okay, it's 46 now. Let's come back at 11:55. Okay, let's come back. Okay. Yeah, apologies about the text. If it's not clear or too small, just let me know. I don't mind increasing the font or changing anything. Okay. Um, so this is our third lab for today, and if we finish this also um, earlier than expected, we maybe will jump to the next one. You'll have the opportunity, of course, to continue that on the labs. But as I mentioned, the agenda, as I said, is very flexible, and these are self-paced. So maybe my pace is fast now. We had technical difficulties at the beginning. I wanted to push through, and I think I pushed through too much, and so now we'll just take it a little bit notch down. But the what I was expecting is to go at least over these three labs or um, cover these three labs. um, Maybe just to go back here, I'm gonna share. There's like this documentation on like skill badges, and then also um, the quests that you could take. Let's see if that opens actually. It's kind of good. Okay, here it is. Close this here for a moment. Let me just share these with you. And I believe like you could find all this information. These are the badge, like what's how to earn or what's a skill badge. You could earn it, how you could share it. And this is for the quests on the cloud skills boost. As you can see here, I think we're taking. It's not like there are 45 pages, I guess, here, so each page is 10, but I'm not sure if that's all of them, but it seems to me like that's all of them. We're actually doing this one, integrate with machine learning APIs, and we've covered the intro, extract, and it goes on. I didn't even finish it myself, but if you finish the up to this the challenge lab, you could earn these skill badge. So you pick your quest, complete the challenge, and then you earn your skill badge, and you could share it on your social profiles or professional profiles, I'd say. Yeah, so that's cool. Maybe you could read more about the impact of these skill badges. Um, and here you could pick any quests you want, any solution. So yeah, there's a lot of them here. So I haven't really done much here, but it's pretty straightforward and actually teaches you a lot. There's a lot of detail in every quest, so I think just take your time and do it on the weekends. And there's I don't know if that's all of them again, but if there's 45 results, I would say you could really finish most of them really short time. Okay, starting this lab. I'll go ahead here. I'm gonna maybe go a little bit more here. Again, what I do is I hit the start lab. Since I shared this with you guys, I'm gonna close them. And we are in the lab number 3 here. Classify text into categories with natural language processing. This just before we start, like we could start, but we have an hour here. So what we'll learn in this lab, we'll just backtrack a little bit. This API, we're using natural language API specifically in all this lab. It extracts entities from text and performs sentiment and syntactic analysis and classify text into categories. And that's what we're going to do. So it focuses on text classification and using the database of 700 plus categories. This API features make it easy to classify a large text data set of text. Yeah, we're talking about Google here, so they have a lot of data. They could really spin up really huge, large resources to be able to train these models that we are using through our API requests or endpoints. So what we'll learn is calling the API using a post request. So we're going to use the classification feature of this API, and we're going to understand the data set of using text classification to understand the data set of news objects. So that's cool. So we need a project and a browser. Okay, cool. So I got, and this is just going over the, starting the lab and using your launch with credits, and then open. I would just right away save the password, open in incognito. Make sure you don't use your account. Make sure it says like student something. Paste the password. Three terms and conditions. Every time you're a new user or using a student account, of course, and I believe there are limits, of course, to what you could spin up resources here, but I am not sure, so I can't tell you off the bat. But it's pretty. When I worked in the Google Cloud at my previous job, it's the same UI. This is, you could, if you're using like different products here, could go more products and pin them to your. But usually by default, it's whatever's pinned here is like mostly used. So we used the bucket storage before. We created an API key. And later in the quest, if we get to it, or on your own, you're going to be creating a BigQuery table or data set. I think you're going to be creating using the API, but it's pretty cool. Everything is on this dashboard. We could see how much you're using, and all that stuff. So let's actually put these beside each other. Usually I spin up the active Cloud Shell as well. Go back. No, that's not where I wanted to go. Okay. There we go. So we've done all that. Continue here. We just increase this as well. That's cool. If this is not good, let me know in the chat. Otherwise, I'll take it as it's good. Okay, so this is again going all over these steps. Activated Cloud Shell. And let's just run these commands again. Just make sure we can authorize. And this is the project ID. Cool. Okay, so confirm that the Cloud Natural Language API is enabled. We're gonna go on the UI. Where did we go here? API and services, enabled, I guess, libraries. Enable API and services, and we're gonna show API. This is the one, and it's enabled. If it's not enabled, just follow these instructions and hit enable. You should see this sign here. Okay, we're gonna create an API key. And services credentials. So we're gonna be using the natural language API, create credentials, API key. Save this, close. Copy that and close, and then let's export it right away. That's what the steps are going to tell us to do. API key, and it's there. Check your progress. You don't have to do the export before this, but I do it because that's always what you have to do. You're going to probably have to do it to make your life easier. Okay, you're gonna open your Commute Engine VM instance. You have an API, VM instance that's already running. We're gonna go check that out. So why? So in order to perform next steps, please connect to the instance provision for you via SSH. This is basically just a VM or like a virtual machine that we're gonna be using to run our commands. So, oh, that's why. Okay, created. Let's see. We created an API key. Okay, that's why we're gonna export that API key on this one here. So not where I did it in the Cloud Shell. We're gonna do it here. I think we're gonna see the reason why we're doing it. Okay, so that's big. Nothing here. Export API key. Cool. Okay, so we basically transferred from our Cloud Shell to a virtual machine to do the next steps. And that's where we pasted our API key as a rental variable. So now we're gonna test with to classify a news article. So we're using that API. We're gonna be doing our classification. Okay, so categories that apply to text document. These categories. So we're gonna this method of the category of the API returns a list of content categories that apply to text documents. So these categories range in specificity from broad categories like computers and electronics to highly specific categories such as computer electronics, program, and Java. So it's good to get really specific. So that's very neat. A full list of the 700 possible categories that they mentioned to us this before. We could go look at it here. So we're going to start by classifying a single text or a single file. And then we can use the same method to classify a large news corpus. So to start, we're going to use this text and save it in a request JSON because we're going to hit the API post by a post request to actually classify this. So let's do this request JSON using your favorite editor. And this is you just copy it, save exit, and that should be there. Let's check our progress. Cool. And then now this is the endpoint for the curl command. Gonna use that. Hit enter. So the text was this: a smoky lobster salad, blah blah blah, and then we use the natural language API to classify this text, and this is the what it returned to us. So if we look at it just a bit in detail, so it classified, it gave us two actually categories. I think for the sake of this lab, we're gonna be using only the first text, that the first category that gave us back. But if it finds like more categories, this is based on like accuracies or like thresholds. It gives us back like what it detected. And so if we read this: a smoky lobster salad with a tapa twist, this spin on the Spanish pulpo, a lug, a lega, skips octopus but keeps the sea salt, olive oil, pimenton, and boiled potatoes. Now that makes me hungry. So that the API returned back with two possible categories that classified this text under. So with this confidence, with food and drink, cooking and recipes, with a confidence of 85%, and food and drinks, food, meat, and seafood with a confidence of 63%. That's very cool. Now we can send this to the okay, we just did that, and then we're just gonna save this output in the results file, results JSON. So let's copy this, put it here, and get the results. That should be there. Let's check our progress. It's good. It's good. So we have two categories. This is a recipe, or even that includes seafood, but the API is able to categorize it, classifying a single article. It's cool. But to really see the power of this feature, classify lots of text data. So, and we have the power to do that with this API. So let's dive into that. So we're gonna try to classify a large text data set. So we could look at the data set. It consists of 2,225 articles in the topics of business, entertainment, politics, sports, and tech from the year 2004 to 2005. And this, I'm not sure if this, I don't think that, I mean, that's a large data set, of course, but I bet there are data set that like expand for longer periods of time. A subset of these articles are in the public cloud storage bucket, each of the articles in the text file. So if we use this command, we're going to be able to see how the text looks like. So let's see, to examine the data, let's use this command. You'll write Python script. So we're going to be writing a Python script. I guess we're going to be just like using, copy and pasting that script. So we're going to store the result in a BigQuery table. So this is actually where we start working with BigQuery. So it's a big data warehouse. Lets you store and analyze large data sets. Just think of it that way now. So let's see what kind of type of data we're going to be working with from this that subset of data that's stored in the bucket. So this is just looking at like one text file, 001, the first one probably. I could read it as just text. That's what we're gonna be classifying to categories. Okay, so now we're gonna create a BigQuery table for our data. So probably easier to work with. So creating a BigQuery table for categorized text data. For sending the text to the natural language API, you need to store the text and category for each article. So let's navigate back to our navigation menu, and the BigQuery, as I should be somewhere here. Let's see, sorry, here. BigQuery. Click on it, and this is gonna pop up, and then you just hit done, as the instruction says. And we're going to be creating data sets. So there's probably this is just metadata or some configuration for the sorry for this data set. We're going to use this. Okay, it's right here. Create data set. Name the data set and use, okay, let's just copy paste this. You paste this in your dataset ID, of course, without the comma, and then hit create. You don't need to configure anything for this. Okay, so now we're gonna create a table. So you could see this is where it got created, the dataset, and we're going to create a table in this data set. So we got some information here that we need to use. We're going to use this following settings: create a table from entity table. Let's write article data. That's what we're going to name the table. That goes into your table here. And then we're going to add these three fields. So if you click on this, you probably could can zoom in, but what it's telling us to add here, just add 3. This is article text. This is where the text is going to reside. Article column, field, category, and confidence. You saw already when we tested with the previous text, it gave us the category and the confidence. So this is where really it's going to be stored, this data. Okay, go back. And this is all we need. Oh no, we need to actually confidence. We need to set it as a float. Yeah, just don't forget that. Or else you're just gonna get probably maybe 0 or 1, or just ones maybe. So create table. Okay, so let's check our progress. That's good. Okay, so now we're task 6, classify news data and storing BigQuery. Okay. So we're gonna connect to the Cloud Shell, which we are connected to already. We're gonna export the project name, so we don't have to. This would be the copy and pasting all the time. Just do it once. So the project name. So export just project. Echo project. That should be there. I run the following commands to create a service account. Okay, so they just give us a command here to create a service account. Nothing to be replaced. Now you're ready to send the data text data to the Natural Language API. Okay, it looks like it worked. No errors. Just make sure there's no errors. Sometimes these are hidden and you might not be able to continue to the next steps. So created key, type JSON as key. Let's see. I have key.json. This is our API key. Cool. Now you're ready to send the text data to the Natural Language API. Write a Python script using the Python module for Google Cloud. You can accomplish the same thing from using any language. There are many different cloud client libraries. So we're gonna create a file called classify text. Just use the same name. Otherwise, you're gonna have to be replacing that in different commands. .py. This is a Python file, and we're gonna be using this code. We're just gonna copy it, and I think we might need to replace something in here. Let's see. It probably tells us. So you go where like the comment says replace to do. So we need to replace this with our project ID, which is this one. Let's see. You could like copy it from anywhere. I don't know. It doesn't matter as long as it's the right one. So yeah, this uses the Cloud API, storage, language, Natural Language API, the BigQuery, to make a client and to instantiate a client, storage client, and also a language client, Natural Language client, and a BigQuery client. And we need to give it a project name. So here, dataset reference. This is the name of the dataset, and this will be our dataset. And this is the reference for the table in the dataset. This will be our table. We have a function here that returns to us the classified text. So this is a call to the Natural Language API classification endpoint, and this is just row for BigQuery, client bucket, list blobs. Okay, so we're sending this text files from the storage into the BigQuery table, and this takes sometimes, I guess, takes 2 minutes. And here, this is we're going over every file to do so, and we append these into the BigQuery table. Okay, yeah, it's pretty straightforward. Just you need to know the syntax, of course, so you know how to communicate with these different APIs in Python. So save, exit, make sure you got the bucket name or the project name up there. This is what we just pasted. Yeah, it tells us here replace with project ID, and we just run the Python classify command. Classify text, we run the file that we just saved. So that's gonna take, I guess, a couple of minutes. So it takes file from the cloud storage. We process these files using the API, the natural language API, to get them classified. And of course, once this is done, we save them in the BigQuery where we could actually view them after. You'll see them in a second. So we get the categories and we get the confidences from the API response. And this is all saved, going to be saved in the BigQuery table. Okay, cool. That actually ended pretty good, pretty fast. Okay, this takes about 2 minutes. Using the Google Cloud, Python client library, BigQuery, and blah blah blah. Okay, so this is just telling us exactly like how the code kind of works. Maybe not exactly, but briefly. It's time to, okay, so let's go and see our data in BigQuery. So this is our table. Maybe we should have showed before that this didn't have anything in it. And now if you go to, this is our table that we created, right? And then if we go preview, and this is preview, and this is where the data got deposited. So this already ran through the API. We already got it classified or categorized. And again, this lab mentions previously that it uses, as you saw before, when we tested with one text, we got 2 categories, and it gives you more than 2 sometimes. But we are just using the first category for the sake of this lab for right now. Yeah, we're getting probably the category that has the highest confidence. So that's pretty good. Looks good. You just read this and see like if that even makes sense. Dollar gains on Greenspan speech. The dollar has hit its highest level against the euro in almost 3 months after the Federal Reserve. It looks like business news. Or maybe other categories could be finance, something like that. Okay. So now we see the data. The data just given us some SQL commands here. So if we go saved, query, new tab, and if you just do this, probably that should work. It just gives you 1,000 of the what we were just looking at. You'll see your data when you query complete. Scroll to the right, see the category column. Yeah, we could see the category column. The category column has the name of the first category. And confidence is a value between 0 and 1, indicating how confident the API is that it categorizes the article correctly. So yeah, it's a first category that we got. So probably like most of them, I would say we at least got one category here. How to perform more complex queries on data in the next step. So let's just look at other queries. So to see what categories are most common in this table that we just created. So compose new query, I think we're here, that's fine. You could just stay on this window. So let's copy this and you could just paste it here. And what do we need to place here? Oh, the project ID. Where is the project? Yeah. So you just can take it from here. This is everywhere. Like anywhere you look, you're gonna find your project ID, and you could just like comment this and run, and that should work. Yeah. So these are the most common categories from the whole data set. Yeah, looks about right. If you want to find the article term for more obscure category like arts, blah blah blah, you could write the following query. Let's try that. So as you can see, the most common query here, it's the news, politics, arts, entertainment, movies. That comes after the least common, I guess. There are a lot of uncommon ones: investing, finance. Maybe 2014, 2015 wasn't that into like these kind of categories. Cool. Politics still. Politics is always a big thing. Let's copy this command. So we're like looking at or analyzing the data or like browsing the data. So that's kind of like what I usually do in any, even as a backend developer, I browse data a lot. If you're building, fetching data, trying to build your data warehouse or whatever. So let's see this and this. Okay. Or you could get only the articles where the natural language API returned a content score greater than 90. Let's do this as well. You could keep using the same window, by the way. You just make sure you comment command or the SQL code that you want to run. This is just going to give us above 90. These are the categories of the text, or text with their categories that the API returned confidence of 90 and above the 90%. So you could explore more of the BigQuery documentation to maybe analyze, or maybe it will help you analyze data in a different way. And you could actually integrate with a number of visualizations tools, so that's actually pretty neat. I didn't actually try this myself, but maybe I'll try it after this. To create visualizations of your categories and your data, check out the Data Studio Quick Start for BigQuery. Awesome, that's cool. So that's finished. As you can see, it's pretty straightforward. So we covered the classified text endpoint of the natural language processing API. We use the curl command. We also use the Python file to interact with these APIs in a code format, Python, and we were able to send. We had these data, or a subset of this data already in that storage they had for us, Google had for us. We used the Python code to actually send these file by file to analyze it or classify it in the API and store it on BigQuery. So that's pretty good. And again, this code in Python that you saw here, it's probably the same code if you're working in your own project or whatnot. So there's same syntax would stay the same. Import and analyze data in BigQuery using SQL. So that's cool. A little bit of everything. So there are, I believe, quests that are very specific to maybe SQL, or so you could go ahead and explore that as well in your own time. So, tells you here what you finish your quest, blah blah blah, take your next lab. So that's good. Let's fit in this lab. So that's actually good timing. They gave us 1 hour for this, and I believe that's plenty of time. Finish this. And if we close this, as I mentioned before, let's just say close this. We're done here. We're done here. You don't have to worry about anything. Close this, and we're done here. Tick label faces and landmark in images. with a cloud vision. Okay, let's actually, this is half an hour, so actually we might be able to finish because we need like a 5-10 minutes after for wrapping up. So maybe we'll finish this pretty quick. So that would be cool. Okay. So the Cloud Vision APIs, we actually use this briefly in the second lab when we actually use it to extract this text from this, like the French text from the image. So we understand content of an image by encapsulating powerful machine learning models and simple REST API. In this lab, we'll send images to the Vision API and see it detects objects, faces, and landmarks. So this is some different. We're going to be using a different endpoint of that Vision API that's going to help us to be able to detect objects or faces or landmarks. So, how to use it with our curl command using the label face landmark detection method of the API. Cool. I think I like this one. So this is the same thing going over. Let's just minimize this and create start lab. I thought this said half an hour, but anyways, use your credits. So password open incognito, and let's beside each other. Let's activate Cloud Shell. Oh, let's increase this. Just tad. Agree. Increase this as well. Oops, what happened here? Didn't want to. Let's do it here. Maybe that's better. I don't want things to. So we're covering just all these steps that are the same pretty much in every lab. Cut this, increase this. Yeah, that's good. Okay. We activate Cloud Shell. Let's just authorize. Make sure all is good. It's the cloud. Get us to the project. I'll be using it here. Let's just make sure we're not opening using yeah, we're gonna be using it. So let's just go good, and we're gonna create an API key to talk to the API. Okay. Credentials. Create API key. You're gonna copy it and then close and check your progress. Good. Let's export the API key. Export API key. Echo key. Good. Okay. Let's upload an image to a cloud storage bucket. We've done this before, and I think we're gonna be doing it here too on the UI. We're gonna create a bucket, I guess. Give it a unique name as well. Let's do that. Storage bucket. Create. Usually I just do this. Not really creative. Continue. That's fine. Same thing pretty much here. This until you get to this end where we're gonna uncheck, I think. Uncheck this and find grain. Continue and you're good. Just create. Everything I'm doing is mentioned here. I might just be going a little bit faster, or maybe that you're not seeing, but um, everything, because I've done it. I've done these, and so I'm pretty familiar with them now. So you're not missing. Basically, you don't have to tie it down or take notes or at all. Right? So, okay, so we're gonna upload an image to our bucket. Let's save this. If you want us to save this image, donuts PNG, donuts.png. I have it saved. I don't know why I keep doing this. Yeah, use PNG. I have them ready to save, but it's okay. Go to the bucket that you just created and upload the file. Okay, so we are inside the bucket. We're gonna just go and upload files, and donuts is right here. It looks like a Kentucky chicken or something like that. Let's see if the API does it as well. You should see the file in your bucket, so it's right here, and we're gonna fix the access. Publicly available. Okay, so let's do it. Publicly available, edit access. I'm gonna add an entry public, and you're good. Save. Okay, so since this step is done, let's just check our progress. Awesome. We're gonna create the vision request now. We could open request.json file, and we're gonna save request. Use your favorite editor, request.json, and we're gonna take this. Probably gonna need to change something in there. The bucket name, yes. The bucket name was, it's right here. No, I think this takes the whole path maybe. Let's try it actually. No, it's good. Okay, and now we save exit. So this is gonna be our file request file for the Vision API. And we're gonna use the type that's gonna be a label detection. I think I can't remember what we had before. And it's similar here, similar configurations. Max results, 10 detections, I would say maybe at most. And this is as you remember before, we could have changed this also in the text section if it's coming from the storage, cloud storage. So here the source would be GCS image URI. This is you don't change this, and this is your V where the images reside. So we call that, we use this file, and hit enter, and we get data back. So this is our response. Should look like this. We look at it here. Okay, so kind of like looks more like gibberish, but it's actually no. It's actually, it tells you the description, food. A lot of annotation actually. MID, as I mentioned before, it's something to do with the graph on Google. Score, it's very confident that it's food. Topicality, so let's see what topicality is. The name of the item, it's a description, scores number 0 to 1. Again, how confident is description that matches what's in the image, and MID. What is topicality? Oh, I guess like how relevant it is to the topic, food. Did they mention it here? No. Probably more in the documentation of this API. Okay, so I would say just like something to do with like the topic that's in the description. how confident is that's that, or like how relevant it is. Uh, so web detection. In addition to getting labels on what's in your image, so these are labels. In this annotation, we got labels. The Vision API can also search the internet for additional details. So you get more metadata through the web detection method. You get a lot of interesting data back. So this is why it's called web detection, because we're actually scraping the web for information. Or not scraping the web, is like we're detecting where this is was mentioned maybe, or where this is relevant or related to, maybe scraping as well. A list of entities found in your image based on the context from very similar URLs of exact and partial matches images found across the web along with the URLs of those images. So it actually gives a lot of information. It's a lot of URLs that you could visit and see how relevant or similar this information is. So you could try the web detection API. I think we're gonna just have to do the. I think let's see. Let's see actually run request. So we might need to change a small thing here. Image source features. So it's web detection, not label detection. Yeah, and everything else stays the same. And we're just going to use the scroll command that uses so the this web detection annotation. Okay, and now with enter, we get a response like this. It's a lot of data, as you can see, a lot of URLs were starting with web entities or some entities. Image return. If you look at some of these entities, the image has been used in many presentations on Cloud ML APIs, so that's you're probably gonna see a lot of the URLs maybe referring back to the in machine learning and Google Cloud platforms. If you inspect the URLs under the full matching image, partial matching images, and pages with matching images, you'll notice that many of the URLs point to this lab site. Say you wanted to find out other images of big nets, but not the exact same images. That's where the visually similar images part of the API response comes in handy. Here are a few of the visually similar images it found. Yeah, so it's a lot of data. If you have time, you could just browse over this and see how these images are similar that the API found. So it's actually, I would say, similar. That's cool. So now you probably really want to powder trigger. That's funny. Okay. So we're done with that. Let's look into face detection, and we should have enough time for this to finish this. To use this method, I have this image already, and we're just gonna upload it to the cloud bucket here. Just make sure your name is selfie. Here it is. Okay, let's check our progress. Okay, so why not? To use this method, you upload an image for this cloud search, right click on the follow image, save it to the computer, selfie. Now upload your cloud search bucket the same you did before. Oh yeah, we need to fix access. Edit access, public, save. Now it should be good. That's good. Just to make sure these are good, like milestones to check where you're at and if there's anything that you didn't do correctly. So we're gonna update the request file. Let's just copy this. We just need to change the bucket name there. So request. Usually just delete everything here, and we need to put the bucket name. So let's just do this. save exit. Call on the vision API, parsing the response. So this is a curl command that we're going to use. You can see vision here. Have the request already good. Annotate, cool. So take a look at the face annotation. Now they gave us a lot of metadata here. Coordinates. There's a lot of data in this file, so anything it sees that's like face-like that detected, of course, with some confidence level, it's gonna put it in this document. And actually, it does. So I think it does gives you coordinates for like the face itself, and also coordinates for each like face that's trained to detect on the face. So that's why you find like nose tip, midpoint between eyes, things like that. So it's pretty cool. This is very handy for a lot of other, if you're developing, I don't know, like you want to just look at the mouth part or things like that. So is there information you missed? 3 years of clip. Okay, this is just copy the version of it. Bounding poly gives the X and Y coordinates around the face in the image. So this is what I was talking about. If the bounding poly, this is like face detection, is a smaller box than bounding poly, focusing on the skin part of the face. So it's just a smaller box around on the face, I would say, and the bounding poly is like a bigger box around the face. Landmark is an array of objects for each facial feature. So these are landmarks. Some you may not have even known about. Yeah, maybe, I don't know. This tells the type of landmark along with the 3D position of that feature. Cool. I guess with that Z index, the Z coordinate is depth. The remaining values gives you more details on the face, with likelihood of joy, sorrow, anger, and surprise. That's cool. So that's the data underneath. I think here. Let's see here. Same. Okay. Joy, likelihood, likely. Sorrow, likelihood, very unlikely. Okay. So I think very unlikely, sorrow. Yeah, it seems like in the image they were all happy, so that's why there's no sorrow. That's good. I think this finishes that face detection thing. Land annotation, so that's landmark annotation. So let's see here. We might need to save this image, which I have. You're going to save it as city.png. Now we're going to upload this one and fix the access. City upload. And let's fix this. This is going to be quick. Almost there. Public save. Okay, check our progress. Cool. Let's fix the JSON request. Let's just put city. I need to put it in right format. And this is not face. This is landmark. Actually, we could have done type landmark. Why there's two types? That's weird. Don't want to save. Just what happened there? Anyways, it's just copied from scratch. We could have used the other file actually. Maybe it would have detected landmark in that, where the detect faces image. Maybe we'll try it after this to see. Now thinking about that. Okay, so let's call the API. This is our kill command. And let's see the output. Similar stuff. It's a very small one here. Probably just works in a slightly different way. So we have coordinates. Okay, so we have description Boston. So I don't know if this is Boston or not. Maybe you know better, but I guess there is score confidence 75%. Longitude. That's cool. So and then now you're ready to call the vision if I is in the same. Oh man. So what did we? Oh yeah, we just called it. So okay, we're good here. MID of landmark. This is for the graph. Its name, description, confidence score, location. That's cool. So explore other vision APIs. So okay, finish the landmark API request, and this is just telling you that you could go and explore more with the vision API methods. Just before we end here, I'm just gonna go and do the, just get that. Oops, request. I'm just gonna do the selfie. See if that gives us. We keep the type landmark, and the same everything, same thing. Is that save as PNG? Yeah. Let's just try this. Does it give us anything? Same command here. Let's see. Oh, nothing. So it didn't detect. So I was trying to do. I know it's tough where the same image that we take faces from. This one. I think this is in Jordan. I'm not sure, but it wasn't able to detect anything. So maybe this is a small model we're working with. I'm not sure, or maybe this is just too hard to detect. It's not a doesn't like it's hard to detect a landmark here. So, but yeah, so that concludes, I guess, our session for today. We played a lot with these APIs. As you could see, it's pretty straightforward. It's fun to work with, I guess, on the weekend or after you work if you still have. Sorry, I'm wondering if this is recorded for. Yes, it's recording. So, oh, sorry, apologies about that. No, there's no worries. It's recorded, and I believe we recorded from the start. Rohan did that. If he's still around, you could confirm with us, Rohan. And yeah, that concludes it. I think let's look at the agenda here. Let's just finish this exit. Leave. And just this here. And just put this up there. The agenda, where's your agenda here? Just go here first. Okay, so we actually okay, we didn't finish actually all the quests. If you sorry, just go back. Here. As you can see, it's in this lab, submit. There is still, so we did the integrate with machine learning APIs today. We finished the first 1, 2, 3, 4, and you still have 3 to go. The third actually piece here is the challenge lab. So once you finish this, you're gonna be earning skill badge. Can we ask questions in the Slack channel as we go through the labs? Of course, yeah, you could ask questions in the Slack channel. And once you finish this, if you like it, and I believe you'll enjoy it, you could. We uploaded pictures today. We created the JSON files and based on like the lab request, but you could also play with it on your own time. I believe you got enough credits to play around. If you have any trouble with accessing this on free using the credits that you got, also approach us. You shouldn't be paying for this for the next, I think, I don't know, 3 months maybe. Or to be honest, I really have a little bit of information how this works, but you could approach us on Slack and make sure that things are working well for you. And yeah, just you'll if you followed along today, which I hope you did, you're gonna just have 2 left here, or 3, um, and I hope you have enjoyed this session. And I'm just gonna switch to the slides if I forgot anything here, and then we're gonna do the wrap up and the price, the gift. So we did this. We accessed the quest. We started the lab, and we're done. Congratulations. We didn't finish the quest, but you'll be able to finish it. And we hope that you continue your learn journey. So yeah, you could keep learning, doing the quests, earning skill badges, share it with your community. You know, you'll try to, even on your own, like use Python codes if you don't want to use the you know, the curl commands as well. That's would be good exercise. The recording, I am not sure, but I'll make sure it's sent to you for sure. Yeah, we'll send it your way. Connect with your Google Cloud community. This is a Edmonton chapter, but we are in this chapter. The organizers we're even like dispersed right now. Like we're not all in Edmonton, but of course you could always connect with us and join us and to organize events and, you know, lead things like this and learn. I learned a lot from just you know, exercising, doing the exercise, and following along the steps myself. It's a pretty neat exercise. I'm pretty sure you're gonna have fun doing it. If you I guess we could also share these slides, but there is, I'll give you this as well. There's a library of like open source projects curated by Googlers here. Make sure you check that out. You know, open source is always good to contribute to open source. And yeah, join community events. This is a Cloud Study Jam number 3. Don't think we have anything coming up number 4. I think that's it. More Cloud Study Jam. We have civic study groups that's on the go right now. You could, for new events, you could check this out. It's just send this your way as well. I believe you have like access to all this information. And if you're subscribed, I guess you're always gonna get like notified with what's coming up. And yeah, that's a wrap. And for the sake of this study jam, we decided that we're gonna give a prize. I just need to put the names of whoever attended today. So just hold on a second, and then I'm gonna spin the wheels to. So 1 second here. Just gonna put your names. Okay, so we have M.A. Henry. It's a pretty short list today, so there's there's a big chance of you winning today. I think we're giving away Google Nest Mini or something like that. And also, once we get the winner, we're gonna be contacting you for an address. So let's see. I believe that's 1, 2, 3, 4, 5. Okay, so let's spin. Let's see who's the winner of the Google Mini. Okay. Pretty sure it's gonna stop right here. Yeah, they do. We're gonna send you We're gonna be contacting you to send you this Google Mini. But we'll talk to you about this because we need like the address, and I'm not sure if you're around this area, because I might have heard that we're trying to send us all close, like in Edmonton, but we'll be connecting, and if anything to do with redoing this, we'll contact all of you as well. So no worries. Okay, well, thank you so much, and we'll see you next time. If you have questions, just send over Slack. Thank you.